Students, in the last class we learnt about the polarity of bonds, in that they have a both positive and a negative charges. In that we have to know about the what is dipole moment. Okay, it is defined as the product of electric charges and the distance between the positive and negative centers in the polar molecule, and its unit is dBA, and 1 dBA is equal to 3.3338 into 10 to the power of minus 30 coulomb meter. And we have to know about the dipole moment for some molecules. Here H2 has 1.84. Here carbon dioxide is 0 because there is linear shape and equally carries the charges in the opposite direction. And polarity it mainly explains the how much ionic and covalent character present in the molecule. If greater the difference in electronegativity, it mainly explains on the basis of electronegativity between the atoms, greater the polarity and higher the ionic character. Here HF has the greatest polarity compared to other elements. Okay, next there is some formula is there. If ionic character is equal to 0, it means difference of electronegativity is 0, then the bond shows the covalent character. If it is 50%, it shows the 50% of covalent and 50% of ionic. And if Xa minus Xp, it means the difference between the A and B electronegativity difference. It is less than 1.7, the bond has more covalent character. Xa minus Xp is greater than 1.7, it has a more ionic character and percentage of ionic character. There is an equation for the calculation of percentage of ionic character, that is 0.16 into Xa minus Xp plus 0.035 into Xa minus Xp whole square into 100%. This is all about the last class. In today's class we learnt about the covalent bonding. In the last classes we learnt about ionic bonding. Next we move on to the covalent bonding. Okay, next we move on to the covalent bonding. In the first class I was explaining you what is ionic bonding, what is covalent and a coordinate bond, and in that covalent bond is mutually sharing of electron. Get it? Mutually sharing of electrons, and it has a definition is there. It is defined as the force of attraction that binds two atoms together due to the shared pair of electrons. Okay, this will be the one definition is there, that is it is defined as the force of attraction that binds two atoms. It means there is some force of attraction that binds the two atoms. Here there is an X and Y is there. Okay, that should be bonded with one single bond that binds with some force of attraction. Okay, due to the shared pair of electron. Here mutually sharing, here the one electron should be shared with the Y and this Y electron should be shared with the X. This will call it as a covalent bonding, or other definition is also there. It means it is the type of chemical bond. It is the type of chemical bond formed by the mutual sharing of electron. by the mutual sharing of electron. Okay, this is also one of the definition of covalent bonding. It means it is defined as the force of attraction that binds two atoms together due to the shared pair of electron. Okay, and this definition also same like this. It is the type of chemical bond. It means it is one of the type of chemical bond that should be formed by the sharing of electron. This will call it as a covalent bonding. If after the formation of covalent bond, the shared pair of electron belongs to the both containing atoms. Here X is shared with Y and Y is shared with X. Okay, then these two electrons should be belongs to X and Y also, and then the X has a 2 electron and Y has a 2 electron. So that's why when after the formation of covalent bond, the shared pair of electron should be belongs to the both the combining atoms. Okay, this is how it will works. It means there is some illustration is there for single bonding and the multiple bonding. Okay, first one is formation of single covalent bond. First we have to know about the formation of single covalent bond. Okay, in that first example is formation of hydrogen molecule. If in your exam they will ask illustrate the formation of hydrogen molecule or other molecule, they have to give. In that first you have to know the atomic number of the given atom. Okay, and then write the electronic configuration, and we have to know about the how many electrons are present in the outermost shell. Okay, it means first we have to know the some main steps are there. This is I am giving for your reference only. Okay, main step, first one you have to know the atomic number of atoms. Okay, next electronic configuration of atoms. Next, how many electrons, how many valence electrons present in the outermost shell. Okay, did you get it? It means valence electrons means here there is a sodium 11, 1s2, 2s2, 2p6, 3s 1. Okay, in the outermost shell 3s1. Okay, how many electrons are present in the sodium? 1. That should be called it as a valence electron. Okay, in that they are giving a formation of hydrogen molecule. We have to know about that hydrogen molecule. It means one hydrogen and another hydrogen should form by the single bond. Okay, in that you have to know about the atomic number of hydrogen is 1. Then electronic configuration is 1s1. Okay, in the outermost shell there is one electron is there for one hydrogen atom, and other hydrogen atom is a 1 and 1s1. Okay, then here we are writing one hydrogen and other hydrogen. In the showing of electron we have to make a dot. Okay, we have to make a dot. Here one hydrogen has one electron in the outermost shell, it means one electron, and here one electron in the, it should be here writing one electron. So they are mutually sharing. they are mutually sharing, it forms a single bond. Do you get it? They are mutually sharing, it forms a single bond. So how it will forms like that, I will show the mechanism how it will form. One hydrogen atom is there. You have to written in the exam like this. Another hydrogen atom is there, and one electron is present in one hydrogen atom and other electron should be present in other hydrogen atom. It means it makes the bond with the axially. Okay, here there are two hydrogen atoms, you have to write, and here also in that they form bond with axis type. Okay, it equivalent to H, single bond H. Okay, this is all about the formation of hydrogen molecule. We have to write like this. First we have to know the atomic number of atoms. Here they are giving hydrogen molecule H2, it gives HH. In the outermost shell one electron is there. You have to write like this. Okay, in the next example there will be others are there. It means in the outermost shell they contain more than 2, more than 5. I will explain you. First you have to know about that. Here hydrogen has one electron. The electron should be written in dot. You already know about in your previous classes. Okay, it forms axially. Here we are writing one hydrogen atom. It should be equivalent to one hydrogen 1. Okay, this is all about the formation of hydrogen molecule. Next, second one is formation of hydrogen chloride. The chemical formula is HCl. If they are not given in the chemical formula, you have to write also. In that previous example, I will say first we have to know the atoms. How many atoms are present? It means hydrogen and the chlorine. In that we have to know about the atomic number. For hydrogen it is 1. For chlorine it is 17. Okay. Then the electronic configuration of hydrogen is 1s1. Next for chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, this is the electronic configuration of chlorine, and you have to know about that. In the outermost shell hydrogen have 1 electron, and in the outermost shell of chlorine it has a 7 electron. Okay, 7 and 1. When it combines 7 plus 1, it gives to 8. It gives 8. It means the hydrogen chloride has a octet rule. Okay, I will explain you. You have to know about that. Hydrogen has 1 electron and chlorine has the 7 electron in the outermost shell. Okay, and here it forms a single covalent bond, and here it forms a single covalent bond. In that you have to write hydrogen has 1 electron. Okay, and chlorine has how much? 7. Here you have to write 1, 2, 3, 4, 5, 6, 7. Okay, here you have to know about the how to write a valence electrons around the atom. Okay, in that there are even numbers are there. It forms a lone pair of electrons. Okay, first we have to form the lone pair of electrons. Lone pair of electron means it contains 2 electrons in one pair. Okay, here also you have to know about that. When it will form the bond formation, we need 2 single electron. We need 2 single electrons. So that's why here they needed 2 electrons, and the other 6 electrons forms a lone pair of electrons. Okay, then here 1 electron is there and here 7 electron is there. Okay, it combines to give hydrogen 1 electron and other electron, chlorine 1 2 3 4 5 6. Okay, now you have to know about that how many electrons are present in the chlorine. 8 electrons. Okay, how many electrons are present in hydrogen? 8 electrons. Then hydrogen gets a octet rule and octet structure, and chlorine also gets a octet structure, because in octet rule the atom should contain say 8 electrons, and when it compares a octet rule, it is a stable compound. It carries both the electrons from the hydrogen and the chlorine. It means in the definition of covalent bonding, it means mutually sharing of electron. That electrons both the electrons should be belongs to the both the atoms after combining. Okay, in that hydrogen, here hydrogen has a 8 electrons and chlorine also 8 electrons. So that's why it is a stable compound. Okay, it forms a single bond. This is all about the formation of hydrogen chloride and also about the single covalent bonding. Here there will be only single covalent bonding, and then we will move on to the multiple bonding. Okay, it means how it will the sigma bond and the pi bond should be formed in the types of multiple bonds. Okay, next is formation of multiple bonds. Okay, formation of multiple bonds. In that it means more than one covalent bond. Okay, between the two atoms. In that there are three types are there. First one is sigma bond, second one is pi bond. Okay, sigma bond means which is axially overlapping, axial overlapping. Next, pi bond means lateral overlapping. It means axially means like that, lateral means like this. Next, last type is covalent coordinate bond, and it is the type of covalent bonding in which shared pair of electron belongs to one of the bonded atoms. Okay, before going to that, let me complete. Sigma bond, you all know that, which is axial overlapping. Pi bond is a lateral overlapping. In that sigma bond is independent but pi bond is dependent on sigma bond, because single bond is called as a sigma bond. When it forms double bond and a triple bond, in that one is a sigma bond and other is a pi bond, and here one is a sigma bond and other two are pi bond. So that's why pi bond is dependent on a sigma bond. Last type, it is a type of covalent bond in which shared pair of electron belongs to one of the bonded atoms. Okay, in that you have to know about that. Previous definition I was explained like that. In that shared pair of electron that should be belongs to both the atoms, but here the shared pair of electrons belongs to one of the bonded atoms. In that, for example, HCl, the 8 electron should be belongs to only chlorine atom, or it should be belongs to hydrogen atom. Both are not belongs to 8 electrons. Okay, did you get it? These are the about the formation of multiple bonds. Okay, next we will move on to the example. Next is formation of oxygen molecule. This is the formation of multiple bonding. It means there is 2 oxygen atoms are there. In that you have to know about the atomic number. Oxygen is 8. Electronic configuration is 1s2, 2s2, 2p4. Okay, 1s2, 2s2, 2p4. In the outermost shell, how many electrons are there? 6 electrons. Okay, the valency is 6 valency. In that, one oxygen has a 6 electron and other oxygen has also a 1s2, 2s2, 2p4 is equal to 6 electron. Okay, then we are writing one oxygen atom. One oxygen atom is there. How many electrons are there? 1, 2, 3, 4, 5, 6. Okay, these 6 electrons are surrounded by the oxygen atom, and another oxygen atom is there. It also contains 6 electron. 1, 2, 3, 4, 5, 6. Okay, here oxygen and oxygen, that should be bonded by double bonds. It means they are mutually sharing by 4 electrons. It means they are mutually shared with 4 electrons, and it forms like this. Oxygen and another oxygen is there. You have to write in that. You have to put 4 electrons and another remaining 4 electrons are here. Okay, and it should be equivalent to oxygen double bond with oxygen. Okay, after the sharing of pair of electron, each oxygen atom achieve a octet configuration. It means they get a octet configuration. Here 6 electron is there, 6 electron is there. This oxygen get a 2 electrons from one oxygen atom, and other oxygen atom get a 2 electrons from another one. It gets a 8. Okay, it is octet configuration and it is stable. This is all about the formation of a oxygen molecule. Okay, next another last example is there. Formation of nitrogen molecule. In the last example, double bond. Here it forms a triple bond. The atomic number is 7. The electronic configuration 1s2, 2s2, 2p4 plus 3, 7. The outermost shell is 5 electron. Okay, next nitrogen is equal to 7. It gives 1s2, 2s2, 2p3. In the outermost shell 5 electron. Okay, then you have to write one nitrogen atom is there. It has a 1 lone pair of electron and 3 bond pairs. Okay, and another nitrogen is also there. In your first PUC classes, you have to know about that, how many bond pairs and how many lone pairs are there. Nitrogen, they are mutually sharing with the 6 electrons. Okay, it gives it forms 1, 2, 3, 4, 5, 6. One nitrogen and another nitrogen. Okay, and it also forms a, and it gets a mutually shared with the 6 electron, and it also gets a octet configuration, and it forms triple bond nitrogen. You have to know about that. you know about that how to form the nitrogen molecule. In that you have to know about that for carbon, outermost shell electrons is 4 electrons. It is 4 bond pair. Okay, next oxygen, it is how much? 6 electrons. It gives 2 lone pair and 2 bond pair. Next for nitrogen, 5 electrons. It is 2 lone pair and 3 bond pairs. You have to know about that. Okay, this will about the formation of covalent bond for single covalent bond and the multiple covalent bonds. In the next class we will learn about the factors affecting the covalent bonds and VSEPR theory. Thank you one and all.